So putting those equations we just saw sort of into some simple pictures, our frequency in general can be thought of going from minus infinity to infinity. And the real part is the cosine part, and its impulses that look like this. The imaginary part is the odd part. That's the sine, looks like that. And as we said before, typically we're only going to worry about the magnitude of the power. And so you just take the sum of the squares, square root of, and this would be the power. When I combine the real part and the imaginary part to make power, I can then take a look at the power spectrum of different kinds of signals. So here's some, and I apologize for sort of the terrible picture. So here we have just a sinusoid, and our sinusoid just has power at those two peaks, right? Regardless of the phase, the sum of the squares, square root of, is going to give us those two peaks. And also, here we have that square wave, and you can see that the power falls off as frequency goes up. And that's what we showed before. And one of the interesting things also is if you take a signal out of some sort of typical natural image or typical natural signal, you take a whole bunch of them, you also tend to find these spectra falling off. And that just is a property of how images are formed by looking at things in terms of natural images.